We grow up thinking rules require a rule book, traffic rules written down, game rules printed on the box. Even a microwave comes with instructions. So when we discover that the universe follows laws precise, mathematical laws, the instinct is immediate, where's the manual? Who wrote the instructions for gravity to pull, for atoms to hold together, for light to travel at exactly the same speed for everyone? Here's the strange part. Physics has searched for centuries and found the rules, but never the instructions. Electrons obey equations they've never read. Planets follow paths they've never calculated. Particles behave according to mathematics no one handed them. The universe does not consult a guidebook before it acts. It simply behaves perfectly, consistently, relentlessly, as if it already knows. That's the mystery. Not that laws exist, but that they exist without explanation attached to them. No page one, no author's note, no operating system screen behind reality. Just patterns that always work. And once you notice that, a disturbing question appears. Are we discovering the rules of reality, or discovering that reality never needed instructions at all? When physicists talk about the laws of nature, people imagine something like legislation, a rule imposed, a command issued, a universe obeying instructions. But that's not what we actually discovered. We never opened reality and found a rule book inside. We found patterns, and that difference matters. Gravity doesn't know the equation. Take gravity. We can write Newton's law in a single line. Later, Einstein refined it with beautiful geometry. The equations predict planetary motion with absurd accuracy. But here's the strange part. The planets are not reading those equations. Earth does not calculate its orbit before moving. The moon does not check relativity before circling. Nothing consults a formula. The equation lives in our description, not in the machinery of the universe. Nature behaves consistently, and we write mathematics that mirrors the behavior. We didn't find instructions. We found regularity. The difference between description and command, this is where intuition slips. In everyday life, rules cause behavior. In physics, behavior causes rules. We observe what always happens, compress it into mathematics, and call that a law. But the law is not pushing the universe. It is summarizing it. If tomorrow gravity behaved differently, we wouldn't accuse the universe of breaking its own law. We would rewrite the equation because the equation never had authority. It had accuracy. The silent consistency of nature. Atoms combine in predictable ratios. Light bends in calculable ways. Particles scatter with repeatable probabilities. Over and over again, nature behaves the same way in the same conditions. And from that repetition comes law. But repetition is not instruction. Nothing tells the electron what to do. It simply never does anything else. Why this is so strange? Imagine opening a computer and finding it runs perfectly, yet contains no program. No stored code. No operating system, no instructions anywhere, just hardware that always behaves correctly. That's closer to physics than the usual picture. The universe does not execute laws. It exhibits patterns, mathematics, discovered or imposed. This leads to a disturbing thought. Are the laws of physics built into reality, or are they the simplest language we invented to describe a consistent world? When we say the universe follows mathematics, we might really mean mathematics is the most economical way to summarize what never varies. The rules exist because the universe repeats itself, not because something wrote them down. The first crack in the idea of explanation. People often say science explains nature, but look carefully. Science explains how things relate, not why the rules exist at all. We can tell you how gravity curves space-time. We cannot tell you why space-time obeys that relationship instead of another. At some point, every explanation ends in a pattern that simply holds. No deeper instruction manual appears underneath. So here is the first unsettling step. The laws of physics are not orders given to the universe. They are observations about behavior that never varies. We discovered consistency and named it law. But consistency is not the same thing as instruction. And that raises the deeper question. If the universe follows rules without reading them, where does that consistency come from? So we've noticed something strange. Nature behaves regularly, and we write equations that match the behavior, but the equations aren't sitting inside atoms like little instruction cards. Nothing is telling the electron, turn left here, accelerate now, conserve energy, and yet it always does. The question becomes unavoidable. How can the universe be predictable if nothing is being instructed? A pattern is not a command. When you see a shadow move across the ground every morning, you don't imagine the shadow is following a rule book. The motion comes from the geometry of the earth, and Sunday, the pattern is not enforced, it emerges. Physics works the same way. The regularities we call laws may not be imposed on matter. They may simply be consequences of the structure matter already has. We don't see the rule operating. We see the inevitability of the arrangement. Symmetry, the hidden source. Physicists eventually realize something remarkable. Many laws of physics are consequences of symmetries. Not orders, symmetries. If the laws of physics don't depend on where you perform an experiment, momentum is conserved. If they don't depend on when you perform it, energy is conserved. If they don't depend on orientation, angular momentum is conserved. Conservation laws are not instructions handed to particles. They are mathematical consequences of the universe being uniform. Uniformity produces regularity. Regularity looks like law. The universe doesn't try. An electron doesn't actively conserve energy. There is no attempt, no decision, no effort. It cannot behave otherwise because the structure of space-time and fields allows only certain relationships between events. The behavior we describe as obeying rules is simply the only behavior compatible with the structure. It's not compliance. It's inevitability. Why mathematics fits so well. People often marvel that mathematics describes nature so precisely, but perhaps the surprise is backwards. We invented mathematics to describe consistent patterns. A consistent universe naturally matches mathematical structure because mathematics is the language of consistency itself. We didn't discover a manual written in equations. We invented equations that compress repeated behavior. The universe didn't choose math. Math is how we describe anything that never changes. Predictability without control. A pendulum swings predictably, but nothing inside it calculates sine waves. Predictability does not require a planner, only a stable structure. The universe is predictable not because something directs it, but because its relationships don't vary. Where variation is absent, prediction is possible. The absence of hidden orders, it's tempting to imagine deeper instructions beneath the laws, a final layer explaining why these rules exist instead of others. Physics keeps searching. So far, every time we dig deeper, we find another pattern, never an instruction set. Fields interact according to equations. Particles arise from fields. Symmetries constrain interactions. But nowhere do we find a page labeled, "Why these rules?" The shift in perspective, we started with the idea that laws control reality. Now the picture is reversing. Reality exists in a particular structure. That structure produces consistent relationships. We call those relationships laws. The rules are not running the universe. The universe is what makes the rules look inevitable, the uncomfortable question. So we arrive at a deeper mystery. If predictability comes from structure, and structure just exists, then explanation stops at existence itself. No instruction manual underneath, no final command layer, just a universe whose consistency allows description. And that leads to a harder thought. Maybe asking who wrote the rules is like asking who wrote the shape of a circle. Why deeper physics removes explanations? Instead of adding them, most people imagine science as a staircase. You explain one thing, then go deeper and explain the explanation, and eventually you reach the final answer, the ultimate reason why the universe works the way it does. That's a comforting picture. It's also not what actually happened. The historical pattern, look at how physics really progressed. First, we explained falling objects with gravity. Then we asked, what causes gravity? Einstein answered, curvature of space-time. Better explanation, right? But now we had a new question. Why does space-time curve according to Einstein's equations instead of some other ones? We went deeper quantum fields. Now particles weren't little objects, but excitations of field. So we asked, why those fields? Why those interactions? Why those constants? Each layer didn't eliminate mystery. It relocated it. Explanations become descriptions. At every stage, what we called an explanation turned into a more compact description. Newton described motion with forces. Einstein described motion with geometry. Quantum theory describes interactions with amplitudes. But none of these levels produced a line saying, here is why the universe chose this system. They just described it more precisely. The manual never appeared. The shrinking role of because. In everyday life, explanations involve purpose. The light turns on because someone flipped the switch. In physics, because keeps disappearing. Why do objects move along straight lines? Because space-time geometry allows it. Why that geometry? Because the field equations relate energy and curvature. Why those equations? That's where explanation ends and pattern remains. The ultimate law problem: suppose we finally discovered a single perfect equation describing everything, one elegant line of mathematics from which all physics follows. Would that explain why reality exists that way? No. It would only mean the universe matches that equation. We would still ask, why that equation instead of another? The last law cannot explain itself. When questions stop being physical, at some point, asking why stops being a physics question. Physics answers. Given these rules, here is what happens. It does not answer why these rules exist rather than others. Not because physicists are lazy, because no experiment can distinguish between the rule is fundamental and there is a deeper reason. The question leaves the domain of measurement, the pattern at every depth. So the deeper we go, the more the same structure appears. Regularity, mathematics, prediction, but never instruction, execution, obedience. The universe does not behave like a machine following a program. It behaves like a consistent structure describable by mathematics. The vanishing manual: people expect science to reveal the final page, the ultimate explanation. Instead, every page we uncover is another pattern. No author's signature, no final chapter titled reason, just relationships that hold everywhere we look. The uneasy realization: the progress of physics has not been the discovery of commands behind reality. It has been the discovery that commands may not exist at all. What we call laws might simply be the shortest way to describe what cannot vary. And the deeper we go, the more explanation turns into description. If there's no manual, is the universe designed? Once people hear that the universe follows precise mathematical rules, but we never find instructions, they naturally ask a bigger question. Does that mean the universe was designed to work this way? It sounds reasonable. Perfect order usually suggests a planner. A clock suggests a clockmaker. A program suggests a programmer. But physics runs into an unexpected difficulty here, because the rules we find don't look like engineered instructions. They look like consequences. Design things contain choices. When humans design something, they pick one possibility out of many. A car could have been shaped differently. A bridge could have been built another way. Software could use different commands. Design leaves fingerprints, alternatives that were rejected. Physics doesn't show rejected alternatives. It shows relationships that appear inevitable once the structure exists. Laws that cannot be tweaked. If gravity were slightly different, stars would not form. If electromagnetism changed, atoms would not exist. If quantum rules varied, chemistry would vanish. But notice the subtle point. These aren't adjustable features inside a machine. They are the conditions under which the structure itself is possible. They don't look chosen. They look required. Mathematics doesn't need instructions. A triangle's angles add to 180 degrees in flat geometry. Not because someone ordered it, because that's what a triangle is in that space. Similarly, many physical laws look less like commands and more like properties of the framework reality has. If space-time has certain symmetries, conservation laws follow automatically. No instruction necessary. The shift from builder to structure, so the picture changes. Instead of imagining the universe running a program, physics suggests the universe is a consistent structure whose properties follow from its form. We're not watching rules being enforced. We're observing relationships that can't vary without destroying the structure. Why this feels unsatisfying. People want a deeper why. Why these relationships rather than others? Physics reaches a boundary here. We can explain how one law follows from another, how symmetries produce conservation, how equations predict behavior. But the existence of the structure itself, that may not be a physical question. Not because it's unimportant, because it cannot be tested. The practical meaning. For physics, what matters is this. Given the structure, everything else follows. The universe doesn't consult a manual. It doesn't check instructions. It simply behaves according to what its internal consistency allows. The quiet consequence: so the absence of a manual does not make the universe chaotic. It makes it stable, because stability doesn't come from being commanded. It comes from being unable to do otherwise. The end of why, we followed the trail a long way. We started with the idea that the universe has rules, but no manual. Then we discovered those rules are really patterns. Then we saw deeper physics keeps replacing explanations with more precise descriptions. And finally, we noticed the structure seems inevitable once it exists. So we arrive at the last question. Will science ever explain why the universe exists this way at all? And here is the uncomfortable answer. Probably not. Not because science failed, because the question itself changes meaning at the end. How explanation normally works. In everyday life, explanation always points to something simpler. The kettle boils because electricity heats a coil. The coil heats because electrons move. Electrons move because of electric fields. Each answer replaces a complicated event with a simpler mechanism underneath. We feel satisfied because the chain ends in familiar parts. But physics keeps digging until nothing familiar remains. Eventually, we reach a layer that is not explained by a deeper mechanism, only described by a consistent pattern. The last layer has nothing beneath it. Imagine discovering a single equation from which every physical phenomenon follows. We would celebrate, but the next question would come instantly. Why that equation? And whatever answer you propose would either introduce a deeper rule, restarting the chain, or end in a statement. That's just how it is. At the final layer, explanation cannot go further without becoming circular. The last rule cannot justify itself. The role of science changes. So science doesn't end in a final cause. It ends in a final description. Science tells you, given these relationships, everything else follows. It does not promise, given a deeper reason, these relationships must exist. We learn how reality fits together, not why existence chose this form over another. Why this isn't failure. This sounds disappointing only if we expect nature to come with a purpose statement. But physics was never a search for intention. It was a search for patterns that never break, and we found them. The absence of a manual is not a gap in knowledge. It is a boundary of what knowledge means. The shift in understanding, instead of asking, why does the universe obey laws? We end up asking, what kind of universe allows consistent laws at all? And the answer is simply, this one does. No external justification appears behind it. Only the structure itself, the quiet ending. So here's the final picture. The universe behaves regularly. We compress that regularity into mathematics. Deeper physics reveals deeper consistency. The chain ends in a pattern, not a reason. The rules exist, but they are not issued. They are not enforced. They are not written down anywhere inside reality. They are just the simplest description of what never varies. The universe has rules, but it has no manual. And science may never give one, because the moment you reach the deepest level, there is nothing underneath to explain it. Only the fact that it works.